Good morning, students. Actually, in the previous class, we already completed our chapter number 5, that is simple machine. Okay, now today we actually discuss about some exercise problem which is in your syllabus, okay, and in your textbook. So, at the first question is for exercise A, take the most appropriate answer. Okay, here at first question, work is done whenever the option is a force is applied, a force moves an object, energy is used, and the fourth one is you gets tired. But here actually the correct answer is for A1. The correct answer is actually B. That means a force moves an object, because if force is applied but there is no displacement, then no work is done. So work is done whenever force is applied and also body moves from a point to another point. So the answer B is correct answer. And the second question is actually the force applied on a machine to do work is called the effort. Okay, this is also option B, because load is the force which actually the object that has to be lifted or moved by the lever, that is load. And effort, what is the definition of effort? We already know the definition of effort, that is the force applied on a machine or on a lever. Okay, and we move to our next question, that is question number 3. The effort required to lift a load of 800 Newton by using a lever having a mechanical advantage of 1.6 is. That is, for this question we have to solve mechanical advantage is equal to 1.6, and here actually the load value is equal to 800 Newton. Okay, we know what is the equation. Mechanical advantage equal to load upon effort. So we have to find out the value of effort. That means effort is equal to load upon mechanical advantage. Load upon mechanical advantage. The value of load is equal to 800 divided by 1.6. That is equal to 800 8000 divided by 16, that is equal to 500 Newton. Okay, so this is 500 Newton. That means the option D is the correct answer for question number 3. Okay, and we move to our question number 4. So the question number 4 is, if the effort lies between the fulcrum and the load, then the lever belongs to which class? Okay, so if effort lies between fulcrum and load, then we can say actually effort arm is less than the load arm. Okay, that means load arm is greater than the effort arm. Okay, so this type of lever is class 3 lever. So option number C is the correct answer, because for class 3 lever we know effort arm is less than load arm. Okay, now we move our next question, that is question number 5. Which of the following is a class 2 lever? The options are pillars, a beam balance, a nutcracker, and four shapes. Okay, so for this question number 5, actually the correct answer is simply nutcracker. Okay, because nutcracker is an example of class 2 lever. So option number C is the correct answer. Now we move to our next question 6. The question number 6 is a pair of scissors is an example of an simply this is lever. Okay, so the option number B is correct answer. Actually, pair of scissors is an example of an lever. Okay, this is actually first class lever, class 1 lever. Okay, now we move to our next question, that is actually question number 7. So question number 7. In this question, actually the mechanical advantage of an inclined plane is always the option number is greater than 1, less than 1, equal to 1 and 0. So here we already know, actually in the class we discussed the question, the mechanical advantage of an inclined plane is always greater than 1. That means option number A. Now we move to our next point, that is our next question, that is a machine made up of two or more sloping surfaces is known as. Okay, that is actually definition of OH. Okay, so a machine made up two or more sloping surfaces is known as OH. That means the correct answer is option A. Now we move to our next type of question, that is B. Write true or false and correct the false statement. Okay, so in this case, actually the first question is there are four types of simple machines. Okay, so here actually is this true or false? Actually the statement is false. Okay, because what is the correct statement? Actually the correct statement means there are total 6 types of simple machines. Okay, total 6 type of simple machines, and these types are lever, inclined plane, wedge, screw, pulley, and wheel axle system. Okay, so this is actually false. And we move to our second question. The load and the effort act at a single point in a lever. Okay, that is also false, because we already know for a lever, actually load and effort act at a different point. Okay, such as for first class lever, we know load and effort is like, actually fulcrum is like between load and effort, and for class 2 lever, actually effort, okay, sorry, load is lie between effort and fulcrum, and for class 3 lever, actually effort is lie between load and fulcrum. That is why we already know the load and effort acts at different point for a lever. So this is actually false. And we move to our next question, that is question number 3. A sewing needle is a which type of simple machine? Okay, this is actually a sewing needle is an example of which type, so that is true. Okay, now we move our next question, question number 4, that is a screw is a special case of an inclined plane. Okay, actually this question actually is given from your book, so this question is also true. Okay, here we already know, actually a screw is a special case of an inclined plane. Okay, because actually a screw is actually an inclined plane wound around a rod. That is why it is a special case of inclined plane. Now we move to our next question, question number 5. Okay, so a single movable pulley is a pulley that has its axis of rotation fixed. Okay, actually this statement is false. Why? Because we already know what is the difference between single movable and single fixed pulley. For single fixed pulley, axis of rotation is fixed, but for single movable pulley, it is not fixed. Okay, so the statement is wrong or false. And we move to our next point, that is a rotating spindle tab is an example of a wheel and axle arrangement. Okay, that is actually true because it is an example. In this case, there is a wheel and axle arrangement. Okay, now we move to our next type of question, that is question type C. Okay, so in this case, actually match the column. Here in the left side we can see one is sewing machine, two seesaw, three wheelbarrow, four ice stone, five chisel, and six is screwdriver. And in the right side there are several types of simple machines. First one class 3 lever, second one class 2 lever, third one OH, fourth one is complex machine, fifth one wheel and axle, six class 1 lever, and 7 is screw. So particularly in this case, actually at first is sewing machine. Okay, so in generally sewing machine is a complex machine. Okay, we know the definition of complex machine. Particularly, what is the definition of complex machine? In a complex machine there are more than one actually simple machine. Okay, so if a machine contains more than one simple machine, then we can say this is an example of complex machine. That is why for particular sewing machine there is a pulley, and there is also a screw. So this is an example of complex machine. So one is go D, and the next one is seesaw. We already know what is an actually example of seesaw, which type of simple machine is seesaw. Seesaw is simply class 1 lever, so it is go with eighth, because for seesaw we know fulcrum is in between load and effort. That is why seesaw is an example of class 1 lever. Now we move to our 3. 3 is wheelbarrow. That is a simply example of class 2 lever. That is, this is B. So in this part, actually we know for wheelbarrow, actually uh, load is lie between effort and fulcrum. Okay, so this is in class 2 lever. And what is 4 ice stone? Actually, ice stone is a class 3 lever, that is A. And what is 5? 5 is chisel. Chisel is an example of OH. So 5 goes to C. And the 6 screwdriver. Okay, so screwdriver is a type of actually wheel and axle arrangement. Okay, that's mean 6 goes to option E. Okay, so this is the answer of the following columns. Okay, and now in this case we move to our next question. Actually, we already discussed the question. The first one is, when is work said to be done? Answer the following questions in short. The first question is, when is work said to be done? Already we discussed actually question number one. In short, if we apply a force to a body and the body moves, then we can say work is said to be done. Okay, this is a very simple question. Now we move down to our second point, that is define a simple machine. Okay, or we can, what do you mean by simple machine? Okay, So in this case, actually, simple machines is a machine by which we can make our work easier. Okay, so this is the actually simple definition. It is a machine that can make our work easier, and simple machines have fewer no moving parts. Okay, so and also we can say simple machines are classified in six different types, that is lever, screw, wheel and axle, wedge, inclined plane, and also pulley. Now we move to our what do you understand by the term mechanical advantage of a machine. That means we know what is the definition of mechanical advantage. It is the ratio of load to effort is called mechanical advantage. So that means MA is equal to load upon effort. Okay. So if load is greater than effort, then we can say actually mechanical advantage is greater than 1. If load is less than effort, then mechanical advantage is less than 1. And if load is equal to effort, then we can say mechanical advantage is equal to 1. So that means mechanical advantage may be greater than 1, may be less than 1, and may be equal to 1. There are three possibilities of mechanical advantage. Now, what is an lever? Okay, so we already know, actually we already discussed in actually in the class what is the definition of lever. Okay, what is the definition of lever? Particularly, a lever is a rigid bar. Okay, that can rotate freely about a fixed point. So lever is a actually rigid bar that can rotate about a fixed point, and the fixed point is called fulcrum. Okay, and on what basis lever are classified? Okay, that means the position of load and effort. Okay, so if actually fulcrum lies between the load and effort, then this type of lever is called class 1 lever. If load lies between the effort and the fulcrum, then this type of lever is called class 2 lever. And if effort lies between the load and fulcrum, then this type of lever is called class 3 lever. That means the positioning of load, effort, and fulcrum actually defines, or in this basis actually lever are classified. Okay, and we move to our next question, that is actually state the principle on which a wedge work. Okay, so this is actually you have to write from your book. Okay, actually in your book there are actually simply you have to use the principle on which wedge work. Okay, so what is the principle of wedge? Actually, we know the some examples of wedge, that is knife, axe, and chisel. These are the examples of wedge commonly used by us. Okay, so in generally, in some cases, the number of inclined planes can be more than two. Okay, when there are more than two sloping surfaces, they generally taper to form a very pointed edge, pins, nails, etc. Okay, these are the pointed edge. That means actually here we use two inclined planes, but for particular wedge system. Okay, a wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge, and this sharp edge is used to cut, slice, and push things apart. Okay, this is the principle. So what is the principle? Actually, at first you have to write the definition of wedge. A wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge, and then you have to write this type of sharp edge. Sharp edge is used to cut, slice, or push things apart. Okay, now we move to our next point, that is actually state the wheel axle alignment in brief. Okay, so actually in your previous class we discussed what is wheel and axle system. Okay, so you have to discuss wheel and axle system in brief. That means you have to write down the definition of wheel and axle arrangement, and then you have to write how it works. Okay, and also you have to note down some examples of wheel and axle arrangement. Okay, so in this case actually we completed our answer the this type of problem, answer the following in short. Okay, and as you can see you have to write down answer the following in details. That means uh, these are the questions. Draw the diagrams to show the position of load effort fulcrum for class 1, class 2 and class 3 lever. What is inclined plane, what is screw, advantage of nail, and list uses of inclined plane. Describe a pulley and how differentiate, already discussed in your class. Okay, differentiate between a single fixed and single movable pulley. Okay, and also mention any three ways by which you can take care of machine. Okay, this question is actually is from your book. Okay, so you already, if you read carefully your book, then you must actually attend this type of question. Okay, from your book you can easily write the answer of these questions from your book. Okay, so actually this is the end of today's class. Okay, in the next class we discuss some different types of question, okay, which is not in your book, but this is very important for simple machines. And we also do some problems about mechanical advantage and efficiency. Okay,